today we are talking about translations and reflections on the coordinate plane. This is Chapter 2, Lesson 7. So we'll talk about a transformation. Make sure you get all of these vocab words in your notes. A transformation is an operation that maps an original geometric figure onto a new figure called the image. Two common transformations on the coordinate plane are shown below. So the first one we'll talk about is a translation on the left. It says a translation is when you slide a figure from one position to another without turning it. Notice here how we took our original B and we're sliding it down. Still looks like a B, okay? The next one on the right is called a reflection. It says a reflection is when you flip a figure over a line. This line is called the line of symmetry. So here you can see they're pointing, and right now they are using the y-axis as the line of symmetry, okay? Towards the bottom here, says a translation is also called a slide. It's when the image or that shape stays the same, and the orientation is the same as that original figure as well. The reflection, again, remember it's called a flip, and it's when it's a mirror of those images of each other. It says the image is the same shape and same size as the original figure, and the orientation is actually different from the original figure. So let's take a look. We'll talk a little bit more about translations. So when translating a figure, every point of the original figure is moved the same distance in the same direction. So take a look at the coordinate plane on the left. It's the translation with 5 units to the right. So here they start out with your original figure written in blue here. We've got points A, B, C, D that make that figure. And it is being translated to the right, 5 units to the right. So notice how if I take my pen and I put it on B, I've got 1, 2, 3, 4, 5. That point, that coordinate point for B is moved 5 units to the right, as well as all the other 3 points on that coordinate plane. Taking a look here, in the middle one, we've got a translation where we're moving 4 units up. So we start here with our figure, JKLM, and we're moving 4 units up. So let's just take a look over at L and move 1, 2, 3, 4 units up and plot your new point. Okay. Then the next one over on the right says we're moving 3 units left and 5 units down. Okay, so they start here with your original figure, RSTU, and they take your T and we move 3 units to the 1, 2, 3 left, and 1, 2, 3, 4, 5 units down, and then we plot our new T point. It says you can describe the translation using an ordered pair A, B. For example, a translation of 3 units left and 5 units down corresponds to -3, -5, right? Because if we're moving to the left, we know that that's going to occur on the x-axis, and if we are moving up or down, we know that's corresponding to that y-axis. It says a translation moves every point, P, x and y, to the new image. We call this P prime. It's whatever that original point was at, plus A, and then whatever that y coordinate point was at, plus B, how many ever points they tell you to move up or down. Okay. Really important here, though, that I want to point out, make sure that your original figure are your letters. Your new figure, the translated figure, notice how they've got this tiny little apostrophe there. That stands for a image that has been translated. It is read, the point, so in this case, the S prime. Okay. All right, so taking a look at our example, this is something that you would see on standardized tests like the MC8s. It says rectangle JKLM is shown at the right there. If it is translated 6 units to the right and 4 units down, find the coordinates of the vertices of that image. Okay, so they give you your answer choices. The first thing that you need to do is read the test item and understand what that means. It says this translation can be written as 6, -4 to find the coordinates of the translated image. Add 6 to each x coordinate and add -4 to each y coordinate. So remember, they asked us to move 6 units to the right. So we're moving 6 to the right, which corresponds, left and right corresponds to your x-axis. And then moving 4 units down, up or down corresponds, remember again, to the y-axis. And because we're moving down, we know that that has to be negative, okay? All right, so to solve that test item, take a look. You know first that you're going to find all of the coordinate points. So you're going to come here and say 2 to the left is -2, and up 1 to k is 1. So there is my point for k, okay, or my ordered pair for k, just as they demonstrate right here. They go ahead and list all the other points, okay, off of the coordinate plane there, and when you translate it, you are adding 6, a +6, to the x, and you are also adding a -4 to the y, okay, point. So when I do that, I know that I translate my new image. Remember, this is also read J prime, K prime, L prime, and M prime. And then it says the coordinates of the vertices of rectangle L prime, K prime, J prime, K prime, L prime, and M prime are 4, 1, 4, -3, -2, -3, and -2, 1. So your answer choice that matches up has to be choice C. All right, so let's take a look and talk a little bit more about reflections. When reflecting a figure, every point of that original figure has a corresponding point on the other side of the line of symmetry. Corresponding points are the same distance from the line of symmetry. So taking a look over here, we've got a figure that we're starting with, and we know that there's a reflection over the x-axis. So we start here and we flip our figure down over that x-axis. It says the x-coordinates are the same, but the y-coordinates are opposites, okay, or they're the inverse of whatever point is on that original figure, okay, and that's important to know. So when you are flipping over that x-axis, when you're flipping over the x-axis, the x-coordinates are the ones that stay the same. Taking a look over here at the right, when you are flipping over the y-axis, so this figure they're flipping over here, you can see here it says the y-coordinates are the same. So when you're flipping over the y-axis, the y-coordinates stay the same, and then those other x-coordinates are actually the opposites, or the inverse of whatever integer is there, okay? Down at the bottom it says to reflect a point over the axis, use the same x-coordinate and multiply the y-coordinate by -1. To reflect a point over the y-axis, use the same y-coordinate and multiply the x-coordinate by -1. Well, doesn't that make sense if we take a look at the one on the right here? If I'm flipping over the y-axis, I know my y stays the same. So over here, 4 and 4 stay the same. 4 and 4 stay the same for that second point. 1 and 1 stay the same. And, 1 and 1 over here stay the same. Okay? So taking a look right now, if I multiply that x by -1, here this point corresponds to this point right here. And if I take my original point, which is -5, and I multiply it by -1, I come up with a +5, okay? So let's take a look at the last example. It says the vertices of figure DEFG are D is 4, -2, E is 5, -5, F is 2, -4, and G is 1, -1. It says graph the figure and its image after a reflection over the y-axis, okay? So here, over the y-axis, we know right now in our head that the y-coordinate is going to stay the same, right? So let's read what it says. It says to find the coordinates of the vertices of the image after reflection over the y-axis, use the same coordinate and replace the x-coordinate with its opposite. So let's see if we can find what these values are. So point G, I'm moving to the left 1, and I'm moving down 1. So point G is, point G over here is -1, -1. Over here at D, I move 1, 2, 3, 4 to the left. This would be point D, and down 1, 2. Down would be negative. Over here again, I move 1, 2, 3, 4, 5 to the left for point E. Left meaning negative, and down 1, 2, 3, 4, 5. Down 5 when you're going down, and remember that means negative. And then point F, I move over 1 to the left, which is a negative 1, and down 1, 2, 3, 4, 2 to the left. That would be 2 to the left. So 2 to the left, 1, 2, and down 1, 2, 3, 4 for my F. Down 4 would mean a negative 4. Okay? Now we need to replace that y coordinate with the opposite. So if I rewrite this, I know that this image right here is going to be, G is going to be positive 1, because we're flipping over the y-axis. It's going to be a positive 1, comma, negative 1, because that y stays the same. D is going to be positive 4, comma, negative 2. E is going to be a positive 5, comma, negative 5. And F is going to be positive 2, comma, negative 4. Okay? This kind of just explains it to you, exactly what I just did. So understand that because we flipped over the y-axis, all of these numbers stayed the same right here. And then you just took the inverse of all of your x values and you wrote them on your new image. Again, I want you to notice the prime symbol. When you are creating that new image from the original image, you label that D prime, E prime, F prime, and G prime. And then lastly here, they just list the ordered pairs like I have for you.